Problem Introduction. Hey everyone and welcome back to the channel. Today we're tackling LeetCode problem 44, Wildcard matching. This is a classic dynamic programming problem rated as medium difficulty, and it's a fantastic question to understand the power of DP. The problem statement is, given a string S and a pattern P, where star matches any sequence of characters, including the empty sequence, and question matches any single character, determine if S matches P. For example, AA matches A star, and ADCEB matches A star B. But ACDB doesn't match A star B. We need to design an algorithm that efficiently checks for this match. Seems simple at first glance, but let's dive in to unravel the complexities and discover the elegant solution using dynamic programming. Let's look at some examples to clarify things further. Understanding with examples. Let's break down a few examples to truly grasp the nuances of wildcard matching. Consider ABC and A?C. The question perfectly replaces the B, so it's a match. Now let's try ADCEB and A star B. The star can represent DCE, making it a match. Here's a non-match, CB and A star B. There's no way to make CB fit the pattern A star B. Another example, Mississippi and Miss star is P. This one might seem tricky, but the multiple star allow for flexibility in matching subsequences. These examples highlight the core challenge, accounting for the variable length sequences represented by star. We need a structured approach, and that's where dynamic programming shines. We'll explore the recursive nature of the problem and how DP helps avoid recalculations, which are rampant in brute force approaches. Our optimal solution utilizes dynamic programming. We'll construct a 2D Boolean array where each cell dpij indicates whether the first I characters of S match the first j characters of P. We iterate through the array, filling in cells based on whether the current characters match or if a star is encountered in the pattern. If we have a star, we need to consider two possibilities. The star matches 0 characters, or it matches 1 or more characters. Handling these cases correctly is the key. We'll break down this iterative process step by step, demonstrating how we build this array to efficiently determine whether the entire strings match. The beauty of this approach is that we cleverly avoid redundant calculations. Let's see the code in Python. We'll start by initializing our DP table. Then we'll iterate through the table, updating cells based on the rules we established in the previous scene. We will need to handle the base cases where either S or P is empty carefully. We'll then walk through the code logic for handling matches, question wildcards, and star wildcards. This implementation will follow the DP table approach to offer optimal efficiency. This isn't just about the code. Understanding the why behind each line is essential. Once you see it in action, you'll understand why this approach is significantly faster than a brute force approach. The time complexity of our dynamic programming solution is O of n times m, where n is the length of S and m is the length of P. This is a significant improvement over the exponential complexity of the brute force method. We achieve this because we solve each subproblem only once. The space complexity is also O of n times m, due to the size of our DP table. While the space complexity is linear in the input size, there are ways to optimize this further if memory is a critical constraint. We could potentially reduce the space usage by only using one row of the DP array instead of the entire 2D array. Although for most cases, this O of n times m solution is already pretty efficient. Engagement break. So, what did you think of that solution? Did you find it helpful? If you've made it this far, you're doing great. This problem shows just how powerful dynamic programming can be when approaching complex challenges. Don't forget to smash that like button if you found this helpful, and subscribe to the channel to keep up with more LeetCode tutorials. Also, let me know in the comments below what other LeetCode problems you'd like to see explained. Your feedback helps me tailor the content to what you need, so don't hesitate to share your thoughts. Conclusion. In this video, we conquered the wildcard matching problem on LeetCode. We started with a problem understanding, moved through examples, explored the limitations of brute force, and finally implemented a dynamic programming solution. We also analyzed the time and space complexity of our solution and discussed potential optimizations. Remember, understanding the underlying principles is just as important as the code itself. This problem is a valuable addition to your interview prep arsenal. Make sure to practice similar problems to solidify your understanding of dynamic programming. Don't forget to like this video if you found it helpful, subscribe for more algorithm tutorials, and I'll see you in the next one. Happy coding!